Hello and welcome to Starfish Maths. My name's Sarah and today I want to talk about the discriminant. The discriminant is a really powerful part of quadratic work because it tells you about the nature of things without having to work them out. It's not so much to do with solving equations as just looking at them and analysing what's happening. Because of that, the most difficult part of the discriminant is spotting when a question is using the discriminant in the exam. It might be to do with finding how many times a curve crosses the axis, or how many solutions something has, or whether a curve and a line touch or not. I'll show you the discriminant and how to calculate it, and then I'll give you a couple of examples when it might be used in a question. So grab a paper and pen. I hope you follow along with my examples, write down anything useful, and I hope you enjoy it. Let's get started. Okay, let's start with the quadratic formula. It's a good place to start. And if you're interested, by the way, in where this comes from, please do check out my other video on deriving the quadratic formula using completing the square. I think it's really interesting and nice to see where it comes from. Looking at this formula, we've got a square root sign. Now, you probably know you can't square root a negative number. If you try to, you'll get an imaginary number, which we're not studying in Core 1. So all you need to know now is if you try and square root a negative number, you don't get any real solutions. That means then that this thing under the square root sign is really useful to tell us if there are any solutions or not to the quadratic formula. So this here, b squared minus 4ac, that's called the discriminant. You don't need to square root it, it's literally just that. So there are three different options we could have. Either it's positive, negative, or equal to 0. Let's look at those three scenarios now. Alright, so we already talked about when it's negative, less than 0, it won't have any real solutions. Roots, if you're not familiar with that word, is another name for solutions. It's where a graph crosses the x-axis. So in other words, this quadratic is not going to touch the x-axis at all. It won't have any roots there. It will be floating above the x-axis. If the discriminant is equal to 0, then you'll have negative b plus or minus 0. Now whether you plus 0 or minus 0, it makes no difference, which means that the two solutions you'll get from this will be the same, so that it'll be a repeated solution. What that means on a graph is that it touches the x-axis and skims it, but it doesn't cross. Lastly, we've got where the discriminant is positive. Now this is the scenario you're probably most used to, and that's when you get two distinct solutions. Now that's just going to cut the x-axis in two different places. You'll get two nice different solutions. Okay, so please do make a note of that if you don't have it already somewhere. You do need to know that off by heart, so you need to understand what the discriminant does in the three different scenarios and what that means on a graph. Now let's look at a couple of different questions where you might get asked about the discriminant. Okay, in this question we're asked to find k. Now we don't know much about it apart from that it's got a repeated root. We don't know what that root is, but the fact that we know it's repeated is really helpful because we know the discriminant will be equal to 0. So if we can work out the discriminant for this quadratic, we'll be able to work out k. Here a is 4, b is k, and c is positive 9. So let's put that in. Okay, when I solved this here, you could have done that using factorisation, using the difference of two squares. I in this case just took it over as square rooted, but you must remember you get two solutions, plus or minus 12. And that's that question done. Okay, in this question we're asked whether the circle and the line actually touch. There are three different scenarios, of course. This is the equation for a circle, this is the equation of a line. So we might have the circle and the line don't intersect at all. We might have that the line skims the edge of the circle and is a tangent to the circle, or we might have that the line cuts in two distinct places. Now, I hope you can recognise that that's a discriminant question. There are three different scenarios. That's when the discriminant is negative, the discriminant is equal to 0, and the discriminant is positive. So actually all we need to do here is get to the point that we've got a quadratic equation and find the discriminant, and that will tell us the answer to the question. Now, because we've got two equations and we're looking at intersections, that's where you use simultaneous equations. So I'm going to take this linear equation and substitute it into this equation here. By the way, I'm assuming you've already looked at circles and you've looked at simultaneous equations here. If not, don't worry, I do have videos on those as well. Go and have a look at them. Alright, solving that then. Okay, do remember when you have any algebra like this, a polynomial or any quadratic, get it all on one side equal to 0. So at this point here, rather than steaming ahead and solving that quadratic, we can actually save time because the question wasn't asking us where does it cut or where does the line cut the circle. It just asks us if the line crosses the circle. So that's actually just the discriminant. We're just finding if the discriminant is positive, negative or equal to 0. So again, using A, B and C, let's work out the discriminant. Okay, do remember that's a negative 5 there, not a positive 5. I've got two negatives, so it's plus. At this point I can see that that is going to be positive. I don't even bother working it out. So it's positive, which means therefore there are two distinct solutions. Which means that the line does cut the circle in two different places. Okay, well that was just two quick examples of the discriminant. Of course it's used in lots of different contexts. So a nice idea is to look at some past papers now and see if you can look through and spot the discriminant question. There will be a question on the discriminant, it's just a question of finding it. Often it's disguised in section B somewhere or part of a section B question. Go and see if you can have a look. Thank you so much for watching and have fun!